Okay, so we're now going to look at solving simultaneous equations by the elimination method. Now this is more efficient than having to actually rearrange equations and draw lines, because we're not always going to have square paper. So the elimination method, the algebraic method, is a lot more efficient. This is the one that we are going to be using basically all the time. So this involves lining up both equations so that the variables are above and below each other. So the y's are above the y's, the x's are above the x's, the numbers are above the numbers. And we're going to carry out an operation, so either adding every part of the equation or subtracting every part of the equation, and it will eliminate one of the variables. Okay, so it's probably clearer if we just go through this first example here, which is using y equals x minus 3 and y equals x plus 5. So we've got y minus x equals minus 3. When we've rearranged this, basically what we have to do is rearrange to get only the number on the right hand side, and we want both of the other variables on the left hand side. So what we've done in both these examples is just taken the x away in the first one and added the x in the second one. Okay, so this is how we always want to set up: the x and the y on the left and the number on the right. So equation 1 and equation 2, you'll see we've matched the y's above the y's, the x's above the x's. Now, we're trying to eliminate one of these variables. Now what that means is that if we were to add these columns together, one of the variables is actually going to equal 0. So if we have y plus y, that doesn't eliminate y because that gives me 2y. But if I've got minus x and I add positive x, that's minus 1 add 1. That does give me a 0. So that means that this x is eliminated. Minus 3 plus 5 is 2. So actually doing that makes this really simple equation 2y equals 2, which is now very easy to solve by dividing by 2 on both sides to give me y equals 1. Okay, so the reason we are eliminating a variable is to give a nice easy equation which we can then find one of our variables. Now, we're only halfway there. We've found one of our variables. We now need to find the x. So this involves a substitution. So this bit shouldn't actually be there, so I'm going to scribble it out. So we know that y equals 1. We now have to substitute y equals 1 into one of our other equations. Now, it doesn't actually matter which one we choose. Choose the easiest one. Now I actually probably would have chosen equation 2 here myself, y plus x equals 5, because everything's positive, which makes our lives a little bit easier. Okay, but in this example they've chosen equation 1, it will work out the same. So y minus x equals minus 3 is equation 1, so we're swapping the y for a 1. So I get 1 minus x equals minus 3, and if I do a wee bit of rearranging and solving, minus x equals minus 4, so then x equals 4. So the solution, there's my two values, x equals 4 and y equals 1, which we are going to always write in a little box at the side that makes the answer very, very clear. Okay, so finding our solution not by drawing the lines this time, but by using algebraic methods. Okay, so let's try example 4 now. So we've got two equations and they've already been rearranged for us this time, so the x and the y are both on the left in each one, so that's one thing we don't have to worry about. We've got x plus y equals 5, that's going to be equation 1. And we've got x minus y equals 1, that's going to be equation 2. So always label them 1 and 2. You'll see later on why it's very, very important to do this, to label your equations. So again, we've got our x's and our y's above each other, so that's fine. So we need to basically decide, in the above solution we added, but we could also subtract. So we need to decide which of these we're going to use. If I added x plus x, again that's not going to eliminate it, that's going to give me 2x. If I add y plus minus y, that will equal 0, so that will actually eliminate the y. So if I add these together, I will eliminate the y's this time. Now I could actually subtract these two, that's another way you could do it. If I subtracted, it would actually eliminate the x's and we would have the y's to work with. But we're going to stick with adding first of all, so we're going to add these two equations together. So literally just adding the columns, so it's going to be 1 plus 2. So draw a nice little line and let's see what we've got. So x plus x, that's going to give me 2x. We know that y plus minus y is 0, so we can forget about that, it's eliminated. And we've got 5 plus 1 is 6. So now you see our lives become a lot easier. We've just got this nice simple solution to get this equation, sorry, to get our solution for x. So we'll get 2x equals 6, we just divide each side by 2, and I'll get x equals 3. So that's one of my variables found already. So now we've got x equals 3, we just need to substitute x equals 3 into one of the other equations in order to find the y value. So pick the easiest one. Again, if we look at our two equations, the first one, everything's positive, so that just tends to be a lot easier. So we're going to substitute into equation 1. So write it down again, it's x plus y equals 5. So that is going to become, substitute the x equals 3 in, so 3 plus y equals 5. So then that allows me to now just take away 3 from both sides, so y equals 2. So x equals 3, y equals 2. Those are my two solutions, and I just need to finish off by writing them clearly at the side in a little box, and that's my solution done. Okay, so if we go on to example B, we can see it's slightly different. The difference is that we're not just working with one x's and one y's, we have higher coefficients of x. We've got a 4x and we've got a 3x. Now, this now poses a problem in terms of if we added or subtracted the x's together, we can't possibly eliminate them, because 4 plus 3 is 7, 4 take away 3 is 1. So neither option is going to eliminate the x's. So we're not actually going to eliminate the x's, we are again going to eliminate the y's. And this is where you need to be a little bit careful with your negative number, addition and subtraction, to work out, are we going to have to add them here, or are we going to have to subtract them to eliminate these y's? Okay, and this is the bit that people seem to struggle with the most, is just with this addition and subtracting, which one is going to give me a value of 0. So we're going to call this equation 1, we're going to call this equation 2, and I'm actually going to do a little bit of working at the side just to make it totally clear whether we're going to add or subtract. So we've got minus y plus minus y, that's our first option. So that is going to be minus y take away y. Minus y take away y is minus 2y. So that actually does not get rid of my y. So let's see if we subtract what that will do. So that's minus y, subtract minus y. That's going to be minus y. Remember, this stays as minus y, but this is going to change into a plus. So that's minus 1y plus y, minus 1 plus 1 is 0. So in order to eliminate the y's, I have to subtract the equations this time. So that is what we're going to have to do. We're going to subtract the bigger one from the smaller one, 1 take away 2. Okay, so that's kind of the hardest bit out of the way, is figuring out, is it an addition or subtracting using this little bit of working at the side. Okay, it's really important to get that right before you do anything else. So now we can just add, we can just subtract our columns. So I've got 4x minus 3x, that's just 1x. This is eliminated, and 20 minus 17, that's just 3. So actually there's no more solving to do here. My x value is 3. So if you get to this point, you should be able to finish the rest of the equation pretty easily. It's now just substituting x equals 3. Again, pick the easiest equation. Now, they both get a negative y, but these numbers are slightly smaller, so I'm going to choose equation 2 this time. So I've got 3x minus y equals 17. Substitute x equals 3 in, so it's 3 times 3 minus y equals 17. So that's going to be 9 minus y equals 17. And if I take away 9, that's going to be minus y equals 8. To get my positive y, I need to divide everything by minus 1. So that's going to be y equals negative 8. So that's just going to change the sign on both of them. So there are my two solutions. I've got x equals 3 and y equals minus 8. So that's my solutions there. So this bit at the start that I was talking about, where we need to figure out, is it an addition or subtraction, that's really the hardest bit of these questions. That's where most of the mistakes are made. So do we add or do we subtract? Now, if we scroll down to the bottom here, there's kind of giving you a bit of a kind of flow chart which you might want to copy down into your jotters to help you just remember, make that choice. Is it addition or subtraction? Okay, so first stage is look at the variables you want to eliminate. So are you eliminating the x's, are you eliminating the y's? So that's going to be basically the ones that have the same coefficient, the same number of x, the same number of y. Now if we go back to example B quickly there, we didn't have the same coefficient in our, we didn't have the same coefficient in our x's, so we didn't want to eliminate the x's at the start, we're only eliminating the y's. So look at that variable that you want to eliminate in each equation. Do they have the same sign? Okay, are they both minus? Are they both plus? Okay, if they have the same sign, then you subtract them to eliminate it. So that's like x and x, you would subtract plus x minus x, that gives you 0. Or minus x, if you subtract them, you get the double negative, and that gives you 0. So if they have the same sign, subtract them. If they have a different sign, add them. And copy that flowchart in, and that should help you make that correct decision to start off these simultaneous equations correctly.